Quadrilaterals, Part 1. Your learning target today is I can reason with shapes and their attributes, and you'll know you're successful when you can identify quadrilaterals based on their attributes. So, three different types of quadrilaterals that we are going to talk about today are the following. So, first we have a parallelogram. Parallelogram, that is a big name, but I see the word parallel in that word, and that is going to be a word that we are going to go over later this week because that tells us about the sides, okay? So look at the sides, and it even says, this is the rule of a parallelogram, that the opposite sides are equal and parallel. So what that means is the sides on the opposite sides, so we have side 1 and side 2, those are the opposite sides because they're across from each other. They're equal, meaning they're the same size or the same length, and parallel, which means that they line up with each other, okay? So they are perfectly lined up, and if I didn't have the rest of the shape there, you can see that, yeah, they are lined up perfectly. So that means they're parallel. So that's the rule of a parallelogram, that the opposite sides are the same length or they're equal, and they have to be parallel. And then, of course, that means that the other sides are the same way, right? Oh, they both go this way. They're horizontal, so yep, they are parallel and they are both the same size. Something else that's very important for parallelograms is the opposite angles are equal. So that means this angle is exactly the same as the opposite one, which is the one on top, okay, and across. So it looks like that would be a what kind of angle? It's a little bit larger than 90 degrees. That is obtuse. So I see two obtuse angles right there. And then when I look at the other opposite angles, we have this one and this one. Oh, they look a little bit smaller. Looks a little bit smaller than that 90-degree angle, which is like an L, right? So if it's smaller, that means I have two acute. So I have two of each in a parallelogram. Let's look at another type of quadrilateral. We have a rhombus. So rhombus has, it kind of looks like a parallelogram, but it follows this special rule. The opposite sides are parallel, okay? That is exactly true with a parallelogram. So that means, yep, the one on top is parallel with the one on the bottom. And same with the ones on the sides. They are lined up with each other like this and like this. That they are parallel. They are lined up perfectly. But this is what makes it stand out. All the sides are equal. So that means this side is the same exact size as the bottom, as the other side, and as the top. So it kind of looks like a slanted square, doesn't it? And this kind of looks like a slanted rectangle, right? The parallelogram looks like a slanted rectangle, and the rhombus looks like a slanted square. And in some ways, they're very similar to both of those shapes, right? We know that squares also have all sides that are equal, which we'll go over a little bit tomorrow. But let's see how the parallelogram and the rectangle are very similar. Let's see. And let's see how they're different. The rectangle is the last quadrilateral for today. The rectangle. So for a rectangle, I'm noticing straight lines, right? Well, in order for it to be a rectangle, the opposite sides are parallel and equal. Well, that's the same rule as the parallelogram, right? And that is true. This side is exactly the same size, so it's equal to the opposite side, the one on the other side. And they're also parallel because they line up against each other perfectly. Okay, it's not like one line's like this, one side, and then the other's like this. Nope, that wouldn't be parallel, but they are perfectly lined up. So what else? Each angle is a right angle. Okay, so that's what makes it a little bit different than a parallelogram. You know that a parallelogram, the opposite sides are equal. That means two angles are the same and two other angles are the same. Well, guess what? With a rectangle, each angle, all four angles are equal, and they're all right angles to be specific. So a right angle is that L shape, which is 90 degrees, and there's four of them. So I have 1, 2, 3, 4. That's what makes that special, and it makes it different than the parallelogram. Even though the parallelogram and the rectangle are very similar, we have two sides that are equal. The opposite sides are equal to each other, and they're parallel, but the angles are a little bit different. And that's what makes that rule for a rectangle different than a parallelogram. So tomorrow we will go over 3 other kinds of quadrilaterals because, of course, there are not just these 3. There are lots of them. But I'll go over the 3 most important ones for tomorrow. So remember, your learning target today is I can reason with shapes and their attributes, and you know you're successful when you can identify quadrilaterals based on their attributes.